So in the previous video, we looked at how to solve this application problem, which was modeled by the equation h of t equals negative 16t squared plus 48t plus 160. When we solved parts A, B, and C, we found several ordered pairs. And I thought it would be nice if we could also visually see these ordered pairs on the graph of the function. So what we're going to do in this video is we're going to look at where these ordered pairs are placed on the graph so you can get a better idea of the trajectory and the path that rock follows as Genevieve throws it in the air. So what we're going to do is we're going to pop over to my Desmos calculator, and you can see here that I already have the function entered. So I have h of t equals negative 16t squared plus 48t plus 160, and you can see the parabola shape that the function creates on the graph. So we have a parabola that is opening down. We haven't done a whole lot of work with parabolas yet in this class. In an upcoming chapter, we will explore them in much more detail, but it's very nice now for you to at least get a visual of this, and you can see where the placement of those ordered pairs are in relation to the graph. So the first ordered pairs that we were asked to find were the zeros of the function. And remember, once you find the zeros of the function, you then can figure out quickly the x-intercepts of the function, or the horizontal intercepts of the function. So what I want to do is I am going to drag this down just a little bit. There we go. Now we can see the entire function. So if you look at, move that too. Okay, perfect. If you look at the bottom of your screen, you can see the two x-intercepts, or the horizontal intercepts. So remember, the horizontal intercepts are the points on the x-axis where the graph crosses. So right here at negative 2, 0, and then over here at 5, 0. Those are the x-intercepts. Now, you remember the question asked us to figure out how long it would take for the rock to hit the ocean, and we said 5 seconds. So we were focusing on the positive horizontal intercept. We said that the horizontal intercept at negative 2, 0 didn't tell us when the rock hit the ocean because it wouldn't make sense for the rock to hit the ocean at negative 2 seconds. It's still a point on the graph of the whole entire function, but for this situation, our domain would be restricted. We wouldn't start until time equaled 0, or until our x value was 0 for seconds. Okay, the next ordered pairs that we ran into were the two ordered pairs where the rock's height was 160 feet above the ocean. So one of those is the y-intercept. So right there at 0, 160. So remember in the problem, Genevieve was already 160 feet above the ocean when she went to throw the rock. So at 0 seconds, that means before she threw it, the rock was already 160 feet in the air. Now, we also found out that the rock returned to a height of 160 feet after 3 seconds. So if you follow my pointer here, she threw the rock up in the air, it hits a maximum height, and then on its way down, it hits 160 feet again. So if we go in and if we look at the table for this function, look at these ordered pairs. Now the ordered pairs, they create some default ordered pairs in there for you, but I can put in 3 for 3 seconds. And look, there it is at 160 feet again. So we had 0 and 160 feet. And then again, we have 3 and 160 feet. So at 0 seconds before she even threw the rock in the air, it was already at a height of 160 feet. And it goes up, hits its maximum height, and then on its way down, 3 seconds after she throws it, it hit 160 feet again. And then eventually it comes down to the ocean at 5 seconds. There's the 5, 0. Okay, and then the last question asked us to find the height of the ball at 1.5 seconds. So that was an input value. So look here, I can change my input values in the table. I changed that one from 1 to 1.5. So when my input value t is 1.5, this tells me that my output value, or my height, is 196. And I can identify that on the graph at the very top of my parabola. So at 1.5 seconds, the rock was 196 feet in the air, which also happens to be its maximum height. And we will explore that later in the unit where we cover parabolas in more detail. I hope this helped you understand the path